All right, guys, here you go. Listen to this as needed. If you want to skip parts because you're good at those, then that's fine. Go to the part where you feel like you need the help. Number one, when you are adding, you are strictly just combining like terms. You could either put shapes, boxes, circles around them, or you might choose to stack up the like terms and do it vertically like that. Number two, super important. I would strongly suggest you distribute this minus or -1 to each of these terms and then combine like, because you're subtracting that. You're subtracting negative, so that makes positive. You're subtracting the 2. So be careful with that. This, you can double distribute. You could also put the x plus 3 underneath and then multiply kind of like old school multiplication and then combine like terms. So both of those will work when you are double distributing. You can always write your like terms stacked up to make it easy to combine them. This one you can either distribute or use FOIL. I would say once you get to a binomial, 2 terms times a binomial, FOIL is going to be your best bet. Same on this one, FOIL. When you have 4x plus 2 times 4x plus 2, write it out twice and FOIL. Distribute and then combine like terms. Distribute and combine like terms. As far as identifying polynomials, let's talk through this. Anything that has 3 terms is a trinomial. 2 terms is a binomial. 1 term is a monomial. As far as degree, you are looking at the highest exponent on a variable. So this one is a second degree. When we solve this, we get 2 answers. If we solve this, we would get 3 answers. Factoring completely when there is a 1 in front of the x squared, these should be easy breezy. Flip the page. Number 11, chant it with me. GCF, GCF. Every time you start out with a negative, that is a GCF. Factor that baby out. And then factor what's left. Put your 2 parentheses down to get you going. Again on 12, as soon as you see that 2 out front, you should be like, oh no, I hope that can go away. It can. Not only can the 2 be factored out, but also an x. And then you have this. The 2x just hangs out in front, just like that -1 or negative hangs out in front over here. 13 again, GCF, GCF. Factor an x out of everybody. And then you should be like, oh, this is easy. It's just x squared. Anytime you see 2 terms, it is going to be either a type where you just have a GCF to factor out, or I'm going to skip down to here. It might look like this type of the second part of 16, or it might look like number 17. So 2 terms, first look for a GCF. If there's not one, it may be one that's more like number 17 down here. So GCF, and then that's all you can do. Again on 15, GCF, GCF. Factor out that 6, and then factor what's left. 16, GCF, GCF. I'm tired of chanting GCF to you, but you got it. GCF every time. If something can be factored out, do it. It'll make your life easier after that. 17, like I alluded to before, that is one of those, it's called a sum and difference pattern, or this we call dots, difference of the squares or difference of 2 squares. X squared is a perfect square, 49 is a perfect square, and there is a minus or difference in the always factor down to this. No GCF on 18. You might use that slide and divide method, the X method, but remember your first term times your term has to equal this first term. Your outside, so that's your 4x times your -5 equals, so the outside and your inside, the 1 times the x, together are going to be like terms, and they're going to make your -19. Last, the +1 times the -5 makes the -5. Next section, we are solving, which is basically you start the same way. If it's already factored, if this first parenthesis times the second parenthesis equals 0, that means that 1 or both of these have to be 0. Excuse me. So you said x plus 1 equal to 0, solve it. You said x minus 2 equal to 0, and solve it. You can always plug these back in to the original to check and make sure they work. Up above, when you're factoring, don't forget you can always FOIL or multiply them back together to check. Excuse me. Number 20, GCF, GCF. When you've got two terms, that's the first thing you look for on every problem, but with two terms, both of those can be divided by 2x. You pull that out front and then put down what's left. Check yourself before you move on. Set both factors, the 2x out front and the 4x minus 5 equal to 0, and solve. All right, so you can see all of this work down here. It's wrong because why? GCF, GCF should have factored out a 9, and then you would have 4x squared minus 1 in here. Both of those are perfect squares. Square root of 4 is 2, put the x on there, and then square root of 1 is 1. So then, but here's the scoop. When you're solving this, these are the correct answers. So in solving, you're going to set each of these equal to 0. So this one's going to give you a positive 1/2, and one of them is going to give you the negative 1/2, but should have GCF'd. May not have affected your final answer in solving, but to be appropriate or to have done it correctly, you have to GCF, factor out that 9. 22, it's ready to factor. Just find the factors and set them both equal to 0. Moving on. Number 23. You cannot have a 12 over here. You have to get that equal to 0. So move that 12 over. Now it's negative 12. Factor and solve. Same on 24. You can't have it equals 27x. Move it over. Then you're like, oh no, there's an x to the third power. That's okay. GCF, GCF. Factor that out. Here's what's left. Factor that. And then, oh my goodness, can we get 3 answers? Yes, we can. X out front can give us a 0. This plus x plus 9 gives you negative 9. And the x minus 3 gives you a positive 3. 25, GCF, GCF. And once you've taken your GCF, the x squared minus 16, that is the difference of the squares again. So that'll factor into those two, set them equal to 0, and solve. And I know I'm going fast. You can pause anytime you need to. 26, no, you can't have equals 100. Subtract that over. And then you're like, oh no, big numbers. That's okay. GCF, GCF. Factor that 5 out. Factor the trinomial that's left, set them equal to 0, and solve. All right, 27, 28, and 29. We've got graphs, and it is asking you to match the equations to the graphs. Well, what these graphs show us are these zeros. So for instance, back up here on, let's look at number 26. If we graphed 26, it would cross at where x is negative 4 and where x is positive 5, because those were the zeros, the solutions, the answers. So on 27, if you solve both of those, you're going to get x equals the negative 2 from the second parenthesis and the x equals 3. So you can see that those are graphed on here. And so that, but then there's another one. So you don't pick that one. You can see that the 3 and the negative 2 are graphed right here on B. So that's how those match up. So check them. Number 29 has 3 solutions. That's why it matches up with A. Number 30, area of a rectangle. This reminds me of the one on your quiz. The length is this, the x plus 3, the width is that. So when you FOIL those together, that is how you get E. 31, you are going to, as I did here, multiply the x plus 3 times itself and then subtract off the x plus 1. So check that one out. Similar on 32. FOIL those first two together and then add that 3 on in the end. Last two, and luckily I can kind of show you both of these. Number 33 says calculate the value for x for the rectangle in number 30 above if the area is 24. So take your work that you did on 30 above, which is x squared plus x minus 6 equals 24. So basically you FOILed out that beginning, but we don't want the 24 on the right. Subtract it over, and then you have the minus 30. Factor it and solve it. Last one, list as many synonyms. Synonyms is the words that mean the same. So you could say zeros, x-intercepts, solutions. Every time we find answers, we're technically finding the x-intercepts. And I know that was fast, but you can pause and listen to what you need to do to get ready for your test. Adios.